The sun reminds us that there's always a brighter side to every challenge. In the morning, as the day unfolds, remember that each moment is an opportunity to excel. Seize it. Good morning, all. Welcoming is an art which blooms the heart and refreshes the mind and makes a mark of respect.
I take the privilege of welcoming our chairperson, Tirumadi K. Dhanalakshmi Ammal, Pro-Chairman Rotarian Thiru R.S.K. Raghuram Sir, Trustee Mr. Surya Raghuram Sir in absentia. I welcome our Principal Dr. D. Vasudevan Sir and Dr. A. Vincent Anthony Kumar, Professor and Head of Department of Information Technology. On behalf of PSNACET management and students, I cordially welcome our esteemed chief guest, Dr. Prasanta Panda, Chief Scientist and Head, Material Science Division, CSIR National Aerospace Laboratories, Bangalore. Welcome, sir. I welcome all the faculties and my dear fellow juniors to the session 1 of day 6 in Student Induction Program 2023. Welcome all.
Through the pursuit of knowledge and the quest for truth, a scientist illuminates the path of discovery for all of humanity. Their work will forever be a guiding star in the constellation of human understanding. I request our principal, Dr. D. Vasudevan Sir, to present memento to our esteemed chief guest, Dr. P.K. Panda.
கல்லூரியின் முதல்வர் அவர்கள் நினைவு பரிசை பேராசிரியர் அவர்களுக்கு கொடுக்க பேராசிரியர் பெற்றுக்கொண்டார். மிக்க நன்றி.
Thank you, sir. To introduce our chief guest, I call Ms. Hashni of 3rd year ECE.
Good morning all. It's my immense pleasure to introduce such a great and versatile personality. Dr. Prasanta Kumar Panda is a remarkable figure in the world of scientific innovation. His journey is marked by dedication and expertise, research and innovation. Dr. Panda's quest for knowledge began at Calcutta University, where he specialized in advanced ceramics, earning a BSc Tech in ceramics in 1987. His pursuit of excellence led him to Dijon, France, where he completed a PhD in material science, specializing in ceramics. He further diversified his expertise by obtaining postgraduate diploma in business administration from SCDL Pune. Throughout his career, Dr. Panda has been an integral part of CSIR National Aerospace Laboratories, Bangalore, currently holding the esteemed position of Chief Scientist. His journey with NAL has seen him rise through these ranks from Senior Principal Scientist to Principal Scientist and Senior Scientist. However, his scientific journey commenced as a Junior Scientist at Naval Chemical and Metallurgical Research in Bombay. Dr. Panda's professional journey is marked by unwavering dedication to advancing the field of material science. His expertise expands various specializations including smart materials, the preparation of piezo ceramics, and the development of lead-free piezo ceramic materials. His exceptional contributions have not gone unnoticed, as he has received prestigious awards such as NAL Young Scientist of the Year and Young Engineer Award from the Indian National Academy of Engineers. Dr. Prasanta Kumar Panda's remarkable journey inspires us all to push the boundaries of knowledge and making a lasting impact on our world through education, research and innovation. He has published 80 research publications, delivered 50 plus invited talks, made 12 institutional publications, 60 plus conferences, presentations and publications. He owns 80 patents and has written 6 book chapters. We are honored to have you here, sir. Thank you.
Thank you, Hashmi, for letting us know about a great personality. A scientist shares not only knowledge but also speaks of curiosity that ignites the flames of discovery in eager minds. In their words, students find the roadmap to unravel the mysteries of the universe. Sir, the stage is yours.
Good morning to all. Vanakkam. It is good to be here after maybe my last visit to the, it was maybe in 2015, I think, 2008 or 9, I remembered. After I gave up 15 years, and it was nice to see the college has grown and I can see that so many students, I think it should be audible to the last, or the last batch also. I hope it is audible. Anyway, it was again, just I would like to thank PSNA College and also specifically Dr. Kathiresan, the faculty member from physics department, who was with us in CSIR NL at Bangalore, and that's where my contact established. And he has been pursuing that I should visit. And finally, maybe this was the day which was there for me to come, and I have just come here. I just asked at the beginning that what sort of is gathering and what is that I should do, and because I'm generally scientist, when I start from first slide itself, it will start with science and all that. He said, no sir, you may have to do little differently. The students are the freshers and they have joined his induction program. So then I thought, okay, I may have to have some slides at the beginning meant for the how they should, what they should do for their career at the beginning, and then maybe little deeper in the science in some emerging areas. So that's what I planned. So it is bit, what you call the mixed things. At the beginning, very basic slides, general slides, and later on maybe some amount of a science which you have to bear with me. Okay, so now let us go for the first slide. Who is yeah, I am. Okay. I will tell. So the first one before. Yeah, next. So this is the topic anyway. You know about the topic. I will straight come to the outlines of the presentation. What I would like to say, I will give a brief introduction, and then there are opportunities, as I mentioned. What are the opportunities and challenges for the students and beyond? Beyond, I mean that even after your 4 years of graduation, and what could be the opportunities. Then about my institute, I will make some introduction, and what is that, what are the opportunities in my institute for the students. And then there are some examples of few emerging technologies, that is hydrogen technology, smart materials, and nanomaterials, and then final conclusion. Next one, please. So if I come to the introduction part, in today's world, there are a lot of challenges and opportunities for youngsters and freshers. You can think of when we are young at your age, perhaps the opportunities are rather limited. The IT has not grown, the basic industries are not that much, the economy was not that state what is today. Today you must be knowing that India is in the fifth best, world's fifth highest economy, and it is growing, and particularly not only the service sector, information technology, but also the basic industries are going. You are in core industries, what I mean, whether you do electronics or the mechanical engineering, civil engineering, they are also growing. And manufacturing things are also coming very big way. So there are a lot of opportunities for the youngsters like you, when you will come out after 4 years, and you need to be focused on few things. I have tried in my slides that what is that you should be doing. The first one, the opportunities are plenty, particularly in India, the largest growing economy in the world, And there are tremendous amounts of advancements are made happening in all sectors, whether defense, manufacturing, aerospace, telecom, infrastructure, infrastructure, all that is happening. Now, nowadays, India is perhaps producing entrepreneurs, those who can provide the jobs. People, the general tendency was that you complete your graduation and look for the job. That was 100%, more or less 100% we are used to do. But nowadays, the youngsters actually have a lot of, they get actually a lot of ideas, and the financial things, help, everything is provided, so that they create their industries and they provide jobs to others. So that is very interesting. Instead of seeking job, now youngsters even provide the jobs. There are new challenges, but these are the challenges I am to say. There is a strong competition. Whatever you do, there will be other people are doing. There is strong competition. Acquiring new skill sets are important. You should be acquiring a lot of skill sets, whether not only your engineering, science, and other things, finance, everything you should manage, the business, how to grow the business, all those skill sets you should have, and to adapt to the new business environment. These are the key challenges for youngsters like you. And therefore, youngsters need to focus, at least during the graduation or undergraduate, these 4 years, you should be able to focus at least the subjects, things, whatever you have selected, you have come after hard work, after the +2, you have got the, you could able to get a seat in this college. And so after that, now you must be a little relaxed, because you are not in a mugging up and writing exams and all that. Now you can take a little bit, enjoy for some time, and get used to this new environment, create friendship, learn the subjects, the skills, particularly don't undermine the learning subjects. Like, many students, they say, okay, during exam we will read some 4 or 5 years question answers and then we come out. And that attitude should not be there, because if you do that, you don't get a practical knowledge of the subject. What you need is that you learn the subject, basic subjects, whatever you work, whether you ultimately work in a different field, but your learning habit and basic fundamentals will improve your actual personality. So that is one thing I must say. So don't believe you'll just writing for the exams and scoring some numbers. Anyway, that will be there. Once you learn, it will be there. So that is one thing. And apart from the learning, book, it is not just bookish knowledge. Apart from that, you should have different type of skill sets. There are plenty now you will come across. So this is the time to fix your goal and work towards achievements. You need to work hard with full dedication and determination. You must develop qualities to overcome any difficulties and obstacles you will face them in future. Next slide, please. So during the learning, what are the main things? Apart from your regular coursework, you may have to undergo some internships. You need to select organizations or industries or abroad or in India, what are the different types of short internships you should do, and therefore you will get a very good networking, outlook, exposure to new technology, all that. You should have a project work. I think there should be minor, major projects, what is there in other places. So these are the things which expose to you that are about a particular subject to study little in depth and in organized manner and preparing a report. So there you should participate properly and fully and learn that how you should do, because this habit will keep you even in future to do proper way. So that's why these are very important. Workshops and conferences also try to attend many. To start with, even if you don't present, you just go and sit and listen to others. And then you think of writing something, take your help of the faculty members and write and make presentations in workshops and colleges. Publications, if some students are really, they look forward more, they can, in a particular topic, you can review them or do some little research with the guidance of the faculty members and publish them. And that is also one more area which you do. And in general, there are a lot of skill developments, whether it is learning various skills, making devices, making swan drones or something, whatever you do, whether doing some software, working on that, all these skill developments are there. These are the main things you just keep in mind. Now this you need to develop these sort of things during this period. So then after your graduation, you will feel that these habits will give you a better person and also better. Next. Now, when it comes to engineering, and after engineering, what is that you should do? I will categorize into 2-3 things. Those students who look only for jobs. Okay, I will complete and I will go, maybe majority also, that after I complete, I will go for a job. So that is for direct employment. So of course, we know that at the moment, majority of the students get into IT sectors in India, so that is there. But don't forget your core subject areas. If you are a good student, if you want to work in core areas also, you can work and you can improve. There is a lot of job satisfaction. So that also you should think. Second is higher studies, whether you go for the India and abroad. So what it looks for this, if you want to go for abroad, you will be knowing all this GRE, TOEFL, other things you do. But if in India, also you can do GATE, and also we have CSIR, JRF. Now if you clear CSIR, JRF, even for engineering also CSIR, JRF is there. And after that, even engineering students, they can join directly for PhD or CSIR, like fellowships, JRF, SRF fellowships, and you can come also to the research line. So they're there. There are IITs, NITs are plenty. Every state has got IITs, NITs, ISERs, NISER, all those things are there. So these are the frontline colleges and other universities also to do higher studies. For management also, you see, basically engineering plus MBA degree is considered is a very versatile because you have a lot of things to do on the business side. So look for also like CAT, MAT, JAT, there are a lot of things. So these are the things you should keep in mind beyond that. And if you are looking for research career, you may have to go for directly for MTech or MS degree and then PhD degree. And that also, for that you require CSR, JRF, SRF, all that. So what you do when you do PhD, you have to have some intense study in a particular area, research area, and then come out with some new things, and those things will help, and finally you can be faculty members or as a researcher, as a scientist in various organizations, whether CSIR, DRDO, all those things you can look for this. So starting also own business and entrepreneurship, that is fantastic. If somebody is having a background of no problem of constraint of finance and there is a family background also, and or he himself has a lot of ideas, it's best thing to start this own business like that. Next, please. So what are the qualities and skills that you should acquire during this period? If you are a student, what are the things are there? See, these things try to acquire as much as possible. It may not be possible for all. Like calmness, you should have very calmness mind. Curiosity, you should be always in a learning. You should be curious to know new things. And domain knowledge, you should improve. Open-mindedness for learning, unless if you are open-mindedness, you will not learn new things. So keep your minds always open to learn new things. Quick learning, intelligence, commitment. You should work hard, you should commitment, subject knowledge, you should improve. You should be interacting. You should not be just on your own. You should interact with many friends, faculty members, outsiders. Then only your knowledge will grow very fast. So these are the things you should get. You should be very systematic approach. Whatever you learn, you should do systematic approach. In today's world, everything is available in your, that is mobile. You search anything, you will Google, it will tell you, or various other things which was not there. Perhaps during our times, we have to really search, and even if you want to have a research article, you have to see some bound volumes which will be lying in some library, in some corner with dust over it. But today, immediately you will be able to download that, you can learn. So when everything is there on your fingertips, I will say that you should make use of these and develop all these things, and ability of data analysis, interpretation, and getting conclusions. These are very important aspects. And excellent written and verbal communication. This is important, whether you are in software, hardware, business person, anywhere in your personal life also, you should be highly interactive. You should be good communication skill, writing skills. So these things, you should think all this during these 4 years, and you should develop them. So what I want to say, so far you are trying, okay, I will get into engineering, I will get computer branch, I will get EC branch, and so to say biotechnology, all that you studied, and you worked hard, you have come here. Now in these 4 years, you should develop these things. Next, please. Research skills, Or you know what is research? Something to study structurally and then something you have to do new. That is research. So research skills are most wanted skills with employers look in a resume. Remember, your analytical background, analysis capability, research things, anything you do, you require research. If you want to have a mobile phone, you will look also which brand, which is good, so like that. You want to have a vehicle, you are doing a research. For everything there is a research. So in companies we require that research and report writing, communication, all these critical thinking, planning, scheduling, all these are very important aspects and please develop. Next. So there are different types of research. One is fundamental research, whether it is Boyle's law, Charles' law, gas laws, all these are fundamental. They are not going to change. The Newton's laws of motors, all these are the fundamental things. Okay? But using these laws and you have to develop the technologies. And that's where comes the applied research. So applied research is all about, finally you develop some materials or manufacturing something which is required for our day-to-day life, and that is based on this applied, this is called applied research and the fundamental research. So you should be working, you should have a knack to work on different things. Next, please. So if you see the research or any project work you do, I will say, not only the research, you start with some literature survey, get some knowledge in that, in a project what you want to do. You know what is the title and then do some literature survey and then do formulate and also do some sort of more experiments on that and then you will generate a lot of data and use that data, analyze that data and finally you will be able to get some conclusions and that's all about the research. Next, please. So now I will come to about my institution. NL has two campuses. One is in Kodiyalli in Bangalore. Both are there in Bangalore. And this is near old airport. The main campus is Kodiyalli where our administration takes place. Bangalore is full of testing facilities for aircrafts and other things. Next, please. So NL is mainly working on, we have a trainer aircraft called Hansa. You must have heard. And also Saras 19-seat multi-role aircrafts. These are mainly required for Northeastern and other, this one in UDAN program must have come. These are the two types of civilian aircrafts. We are mainly working on civilian aircrafts, while HAL, which you must have heard, Hindustan Aeronautics Limited, that works mainly for the defense-related projects. Next, please. So, major R&D disciplines, the departments, what you will find in our college is all that, from civil engineering to electronicals, all the civil aircraft, MAV, design and development, computational fluid mechanics, all this you see. And of course, I come from the material science division, aerospace, electronics and systems, electromagnetics, parallel processing, wind energy, all these things. All branches of perhaps engineering you will find in our institute. The research is going on. And all that towards aerospace-related projects. Next, please. So in material science, we have three or four, mainly four different things. One is metallurgical engineering aspects, metals, dealing with metals and its failure, its fabrication, that is metal. We have ceramics, high temperature ceramics, functional ceramics, sensors and actuators. We have smart materials, which is both ceramics, metals and polymers, and then some functional materials. Next, please. So what are the recent research topics in material science? The recent research topics are mainly based on energy materials. See, energy is very important. As you know, in energy also we are moving from fossil fuels to renewable energies where there is safer energies, no pollution, no carbon dioxide, carbon monoxide formation, therefore no pollution. So towards that renewable energy, whether battery materials, now also hydrogen energy. So that is the main sector what is coming. So the students should do projects in these areas and maybe look also near future also your career in these areas. Those who want to remain in core sectors because these are the emerging areas and lot of funding and opportunities are available in the future. So similarly, you have nanomaterials has been continued. We are also working on that. And nanofiber technology and various fibrous materials. Then we have smart materials. There are materials called smart materials. Why they are smart materials? Now, they are able to understand the surrounding, what are the parameters are changing, and accordingly it is able to react. I will discuss in my research content. Next is biomaterials, environmental and purification, functional materials and hydrogen energy and coatings. Next, please. So when it comes to materials, there are metals, polymers, ceramics. There are 3 different type materials. Hope you know about it during your +2 level, and their composites. In ceramic materials also there are different glass, ceramic products, refractories, abrasives, cements, advanced ceramics. So these are the final more classification on that. Next, please. So when it comes to career in research, suppose if somebody wants, generally we take candidates at master's and PhD program, and then one can do a master's project work, and also PhD thesis also one can enroll, and for that one has to clear CSIR, JRF in future. And then for BE, BTech also candidates you take, but for some sort of internship for a brief period, not large numbers but less numbers. So that is all about the opportunities for the students, young students who wants to work in NL in some form of research to start with. Next. But I'll see now, there are CSIR, there are 37 laboratories in the country. Nearby in Karaikudi you have SICRI, Central Electrochemical Research in Tamil Nadu. But you will have Trivandrum also, National Institute of Science and Technology in East Trivandrum. So a lot of the NL comes under this, NCL Pune, all that, there are 37 laboratories. And all these laboratories together, they have a ACSR, our academic platform where the PhD and master's programs are awarded from there. So you can find the advertisement every 2 times per day, per year, and there one can enroll for master's and PhD also. This is just for your information beyond after graduation. Next, please. So there are research themes, what is interesting. One is energy and energy materials, hydrogen energy, batteries, lithium-ion batteries, solid-state battery, biofuels, all those things, ceramic batteries, all that, SOFCs, solar energy, wind energy, hybrid energy, geothermal energy. These are all very, very important because energy is the main thing. What is there is a lot of research required to not only to bridge the gap, but also to go for the clean energy. We don't require fossil fuels more because you see a lot of climate changes and a lot of floods and different parts of the country. You see there are heavy flooding and other parts there is no rain. So that sort of situation is coming because of the carbon dioxide level is very high, which is called a greenhouse effect. So that to reduce that, so these energy materials are very important and one should work on that. Then of course, recently, as you know, whether it is artificial intelligence and IoT, data analysis, robotics, or if you want to do MAVs, UAVs, these are plenty of areas, scopes, and which was not there before. And for you, there are a lot of areas and a lot of new areas emerging. I feel there are a lot of opportunities and a lot of challenges for that also because you have to acquire a lot of knowledges very fast and then contribute. Next, please. So some emerging technology we will discuss. Next. You must have seen this sort of, that has come in the newspaper in 2020. You know what it is actually? It is in a house of concrete which was made in Kanchipur. What is the news? This is like any other house. What is the new there? Now, next slide, please. Now, new is that this is a 3D printed concrete house. You must have, I think, knowing about this. Otherwise, you can go and Google it. What is this 3D printing, this one? Recently, one post office which was 3D printed, made by 3D printing, it was inaugurated in Bangalore in the last few days before. And what it looks, it is a 700 square foot building, and it was done, you can see, L&T constructed the last year, this one. And this was all done with only about few hours of printing. Next, please. Next. Before that, Previous one. No. Previous. No, sir. Previous, not previous. Yeah. This one. Let it come. No, are there? Next. You are going actually behind. Next is okay. Move forward. Forward. Forward after. Forward. Yeah. This one. See, the building project was executed at an open project site and completed within 106 printing hours. That's all is required. That means what? Now this 3D printing technology is the fast way of doing houses. 3D printing like you are doing a printing. So whole thing that in three-dimensional form, a layer by layer, different layers will be deposited and it will be fabricated. So within a very short time. And these sort of things are required for fabrication of low-cost housing in the country, which the government of India is also projects. So this is just an example. Next. Now I will come to hydrogen technology. Perhaps this is the new area. I thought I will leave some few slides for the just for you to remember, okay, some hydrogen energy and what is that preliminary thing, so that if those who are interested to get into more, they can browse further or they will get more knowledge from the Google. Next. So introduction, here what you can see, the world energy demand is continuously growing because of urbanization, population growth, everything. And also due to conventional fossil fuels, the pollution level is also growing. That is called greenhouse gases. And then ultimately, in Paris Convention, it was decided that we should have zero emission finally. And that was set a target of 2050, but it looks that is now shifted towards 2070. So every country is trying to have a minimization of use of this one and include other energy forms, whether solar, wind. So green hydrogen is also one form of energy, because hydrogen, once it will burn, it will form the water. And there is no carbon monoxide, there is no carbon dioxide. And that's why it's interesting. And so zero emission, the target is 2050. And this technology is very important. Not only is production, and also transportation and storage is very challenging, because hydrogen is a very explosive gas. And so this is the main area, and fundings are more available. As you can see, it is driven by not only at some science and technology level, by the directly by the country's administrators at the highest level. So this is taken care of. So this is one emerging area I should tell. Next, please. So as you can see here, the 70% of the matter consists of hydrogen. And the hydrogen word comes a Greek word, which is nothing but it is water former, so which forms the water. Because hydrogen reacts with oxygen, it forms the water. That's why the name hydrogen is given. It is a Greek word. And see, the hydrogen is used for production of ammonia. Mainly, currently, whatever fertilizers you use, ammonia-based fertilizers, ammonium sulfates, disulfates, all those things. And in ammonia, hydrogen is the main material, NH3. So hydrogen, there are 3 atoms are there and 1 atom of nitrogen. So this hydrogen is utilized there in oil refineries to reduce the content of the sulfur. Hydrogen is used. And this hydrogen will grow about 5 times by 2050, estimated. So this is such is the demand. Next, please. So if you see here the graph, you see the one which is decreasing. Previously, we are used to have some wood, charcoal, all that, we are using in villages, still we use them. So that is decreasing. Then similarly, the liquid form also, whatever oil, all those things, that is also decreasing. But it's the gas form which is going up. So we started with methane, and then all that things, and finally it is ending with the hydrogen. So by 2150, you will have the hydrogen energy is the more dominant use. So that's why you should look for to participate in something, whether hydrogen production, storage, application, all that you should look. Next, please. So what are the different types of hydrogen? There are different color codes are there for hydrogen. So just to give you, that's called green hydrogen, blue hydrogen, gray hydrogen. In green hydrogen, the hydrogen is produced by a process where carbon dioxide is not going to atmosphere. There is no emission. Then it is green. And in green hydrogen, mainly the energy required to prepare this hydrogen is also used by renewable energies, that is whether it is solar energy, wind energy. If that is used, then it is become green hydrogen. Similarly, in case of blue hydrogen, the carbon dioxide, because mainly from hydrocarbons, if you decompose by applying a heat, and then if you collect that carbon dioxide, you are not emitting to the atmosphere, then it is a blue hydrogen. But in gray hydrogen, the carbon dioxide is also emitted to the atmosphere. So as you see, the main thrust is for the green hydrogen, where we have nothing to emit carbon dioxide or any fossil fuel gases. At the same time, we are using the natural source available energy to prepare this. So that is more importance given in the green hydrogen. Next, please. So in green hydrogen also there are different methods of production. Photochemical method by light. Photo is light. Light chemical, because light with heat, that is thermochemical. And also electrolyzers by this is the more popular one, and electricity is prepared. So there are different things. I will skip next one, please. So the global scenario is that there are about European 33 countries at 26th Conference of Paris signed a 5-point Glasgow breakthrough pact, and the production of 5 million tons of green hydrogen per year 2030, that is the target they have mentioned. And uses of hydrogen when it comes, you can see there are chemical industries, transportation, fuel cells, but mainly thing it is again the fertilizer things, fertilizer, metal production in metal industries, even production of the metal in the blast furnace. Now hydrogen is injected about 10% instead of hydrocarbons. So that is going to be the green metals, green iron, some sort of. So all these things, wherever you use the pure without carbon dioxide, all the things, then the word green comes into picture. Okay, next. So hydrogen production also by different routes, steam forming, electricity classification and cracking. I'm just given this. You can go through details because it will not be possible for you to learn, and that too in such a big gathering with a lot of noise. I see a lot of, it is very difficult to concentrate maybe for you, but I'm just giving you the different types of production methods for you, those who want to learn on this and get the next one, please. Then I will come to the smart materials. Okay, next. Now, what do you see here? What is the materials? Those who are having sensing, they can sense what is happening. Okay, if the temperature is changed, if pH is changed, if some electrical resistance or conductivity is changed, if that is able to sense and according to acts towards minimization, then that is called smart materials. So it has got a sensing part, that is sensor part, and also actuator part, the other part what it is to act, actuator part. So for example, piezo materials comes under smart materials. Piezo is nothing but the Greek word again here, pressure. Okay, the pressure. So piezo electric means the pressure electricity. The electricity produced by applying pressure on a material. So that material is piezoelectric. So as you can see in the first one, in the direct effect here, so you apply, if you apply it directly the pressure, so it generates the charge. So if you apply the pressure, compressing pressure, it generates the charge. In the second case, you apply the voltage, it creates the strain. So when you apply the voltage, it creates the strain. And so that is called actuator. application and actuator mode, and this is sensor. The first one is sensor mode. So next, please. Next. So there are different types of smart materials, and different inputs are there. Sometimes you have to give heat energy, and you get the shape is changed, and that is shape memory alloys, electrolytical fluid, optical fiber, and magnetorestrictive material. With applying electric field, you get the mechanical strain. So we will get details actually, again, if you do research, but I'm just giving just the background, what are these smart materials. Next, please. So if a structure, in a structure, suppose aircraft structure, it vibrates, okay? Now, when it moves very fast, that is measured, the movement or the speed is measured by Mach number. One Mach number is nothing but the velocity of sound. So 330 some meters per second. It's double, second, 2 Mach number, 3rd Mach number, like that. When the speed increases, the vibration on the wings and everywhere it will be more. And to reduce that, this smart structure concept is applied. So where the piezoelectric sensor will be measuring the vibration, and it will give you feedback, and that will act as actuator to compress it. So that way the vibration can be minimized or it can be nullified. And that is done by a control unit by electronics, and that's where the whole thing is called smart structure. Next, please. So you can see in aircraft various places where these noises happen, flutters happen, cabin noise reduction, central unit, all those things are applicable. Next, please. So this material was developed in a laboratory. This is just to show that this is a work carried out in a laboratory, and we could able to successfully develop this material. Next, please. And this was upscaled from a lab scale to up to 10 kg per batch. We prepared this material. Next. Next. And finally, as you can see, the technology was transferred to industry, non-exclusive license of PZT powder technology, which was done to a industry in IPA Limited in Bangalore. And this was the signing, MOU signing of the transfer of the technology. So what do you need to do? You must work when you are working for research, keep an application in mind and do the projects and that. Whatever you do a project, you think that for what I am doing it, what should be the application, like that. So similarly, when you develop a material, we think whether it can be taken up to the production level. And now the company is making and producing this material and is selling, and also is making accelerometers, and it is supplying industrial level. Next, please. So there are a lot of application of these smart materials. See, MAV application, high temperature sensors, energy harvesting, vibration control on smart shoes. So these are the materials will be there in shoes. So if you walk, it generates charges. You can have your mobile, it can be charged while walking, while jogging, while running. And this is a very interesting, these sort of projects also I found that many students, they came to do these projects, they wanted my help. And this is a very interesting topic for the students to do, like energy harvesting using PZT materials and then charging batteries, all that. So precision fluid control, ISRO, structural health monitoring. Next, please. So also piezoelectric materials with wind energy, it can be clubbed. You can have the PZT bimodes. So when wind is blowing, when the windmill is blowing, with that pressure it will generate some charge, and that charge also can be harvested. Next. PZT devices are already laid down in the railway tracks. So what it does, if any vehicle is moving under the vibration, and that also generates some charges. And even it is there on the roads, in road plates are also, in USA they put it, and then so that that energy is utilized for lighting the street lights in the evening. So all the thing is, this is one more area where the production of energy from using PZT materials. Next, please. So this is a typical work a student carried out with us for the generating the energy by keeping the PZT things, as you can see, for the mobile phone. And you can see the measurement of the voltage there. So he was pressing, he was applying pressure on the PZT, and that was generating incrementally, it was increasing its voltage. So that's what done. Next, please. It is also applying in automobiles. Whatever you see now today, higher form of automobiles like BMW cars and others. Now their PZT-based fuel injectors are applied because it will control the fuel, only required amount of fuel it will only supply. It will not supply more, and if you supply generally currently solenoid-based things, that generates about 15% extra fuel it allows, and therefore that adds to the pollution. So this is the benefit of having piezoelectric controlled, smart material controlled things, that is fuel injector system. Next, please. Similar naval applications. If you want to see the naval or the ship position after far away of any other countries, so you can send a signal and it will reflect from there, and knowing the velocity of sound, you will be able to find out at what distance the ship is there. Accordingly, you can plan. So they are very good in for our naval defense system, and so this material is there. Next, please. To measure the in-depth of the sea, again PZT is used, smart material is used to measure. It goes there down and comes the wave, and then you will be able to measure. Next, please. There are high temperature materials also we have developed. Next, please. Next, please. These are the gas turbine. You know, GTRE, there is a gas turbine research establishment in Bangalore. Now, these engines are there in aircrafts. We have been developing Kaveri engines, and the temperature goes up to 1100 degrees centigrade. You require materials to measure its temperature. You can't use a thermocouple there. And so for all that things, you can also require different materials, and also that is developed in our laboratory. Next, please. So it should have a linear behavior, and that's what it is having, as you can see. So that's what is required. Next. Then coming to little nanomaterials. Okay. Now you can see what are these nanomaterials. Now if you see in the sizes of various materials, you can see even in platelets at 10 micron, you know, human hair, virus, atom, sand. So you can see that is higher side to here 0.1 nanometer when it comes to atom. So these are the thinking about the nanomaterials. Next, please. So if you have one cube of 6 centimeter square surface area, now when you break them into nano, it becomes, you see, in 60 there are 6 zeros centimeter square, and that forms actually out of when you make it 1 nanometer. So what is important? It increases the high surface area and surface energy. Next, please. So if you decrease from the millimeter to this nanometer, your surface area of this material increases exponentially. Okay? And because of this high surface area, it has high surface energy, and therefore this is interesting. Next, please. There is a quantum effect when it is materials becomes nano, and their color also changes. So in gold has got different types of colors when the particle size is reduced to nano. Next, please. So what is the nanofiber? What is a nanofiber? Nanofiber is nothing but whose diameter is perhaps in nano range, less than 100 nanometer or 0.1 micrometer. So these are the preparation methods what we are having in NL basically, and this is called electrospinning process, and you will see like a chemistry lab, there is a clamp stand which is there, and you have a syringe but it has a metallic needle, and you apply high DC voltage, and the polymer solutions can be made into nanofibrous form, pan nanofiber, all barium titanate, aluminum nanofibers can be formed. This is a very interesting area, it has a lot of applications. Next, please. Now this polymer nanofibers have a lot of applications in various things, and so these are the areas we should just keep. Next, please. So similarly, this is mainly used for water filtration, for biotechnology, for growth of cells and like that. So this is the nano area. This is just to know what is this smart material, what is nanomaterials, what are these energy materials, just to keep in your mind. Next, please. I'm not going anything in depth. So this is also the membranes what is prepared for the filtration. Next, please. So I am coming to the conclusion. Now there are a lot of opportunities and challenges for freshers and young engineers, those who are also passing out and those who are currently inducted. So there are a lot of opportunity challenges. One is to fix a goal and work hard, very hard towards achieving this goal. And that's what is, from my side, is the message to all youngsters. I feel I have tried to give an overview. So thank you very much.
Thank you, sir, for your brief on opportunity and challenges for young engineers. Gratitude brightens even the darkest of days, casting a ray of hope and resilience. When we give thanks, we create a ripple of goodwill, fostering connections and spreading warmth. I thank our chief guest, Dr. Prasanta Kumar Panda, for his presence and guidance. Thank you all for being a part of this event.